Hello, this is Kai-Han Krippendorff, tuning in to let you know how much we've enjoyed sharing our conversations and insights with our guest speakers with you over the last 3 months. In a moment, you'll hear our latest conversation about becoming an AI-first company with Ash Fontana. But first, we wanted to let you know that the Outthinkers podcast will be taking a small summer break. After this episode, we'll see you back here on Friday, August 27th with Dave Ulrich, who will share his groundbreaking insights on optimizing organizational health and leadership. If you haven't subscribed yet, make sure you do so you don't miss our upcoming episodes. See you then and enjoy your summer break. Welcome to the Outthinker podcast. Each week, we talk with forward-looking strategists and innovators that are challenging the status quo, leading the future of business, and shaping our world. I'm your host, Kai-Han Krippendorff, founder of the Outthinker Strategy Network. Ash Fontana became one of the most recognized startup investors in the world after launching online investing at AngelList. He then became a managing director of Zetta, the first investment fund that focused on AI. The firm was the lead investor in category-defining AI companies such as Kaggle, Domino, Tractable, Lilt, and Invenia. He has appeared in Fast Company, Bloomberg, Forbes, CNBC, and at the UN. Ash previously co-founded Topguest, a founders fund-backed company that built customer analytics technology for companies like United, Virgin, and InterContinental. Topguest sold in an 8-figure transaction 18 months after the company was founded. From his experiences, he's written his first book, The AI First Company, the definitive playbook to putting AI first in every business conversation. The playbook is an executable guide for applying AI to business problems, made for real companies with real budgets that need strategies and tactics to effectively implement AI. In this podcast, we'll dive into the topics from his book and really understand how you can apply these concepts to infuse AI in your organization. In this session, he's going to share with us why the concept we often hold about AI, this idea of a big brain in the sky, is unhelpful, and how we should really be thinking of AI, what it means to be an AI-first company, practical steps you can take now to start moving your organization on the path to being an AI leader, and how you build your AI flywheel. Ladies and gentlemen, Ash Fontana. Ash, thank you so much for being here with us today. Where are you joining us from? I know you live on 2 different continents.
I don't disclose my location because it's always changing.
Oh, okay.
So I spend a lot of time in the UK and Europe, but I still have a good base in San Francisco. And I just try to find really good machine learning research, and I go wherever it is.
That's great. Love it. Well, thanks for being here with us from wherever that is. So I've read through your book. I've listened to several podcasts, and I'm very curious because this is the book that for me has taken what seems a very mysterious topic and actually explains it in clear language that strategists can execute on. So I'd like to just warm up by asking, what do you mean by an AI first company? What does that look like?
Well, firstly, that's great to hear because that was my goal with the book, to make this topic accessible to people who actually have to make decisions in business every day and use it in business every day. So that's great to hear. An AI first company, sort of annoyingly, is a company that puts AI first. What does that mean? It means in every conversation. And so all the sub-strategy conversations, so pricing strategy, sales strategy, and product strategy. And what it means to put AI first in those conversations is to consider things like, well, how do we price our product so that we encourage usage and therefore data collection, therefore improving the underlying models? Rather than how do we price our product to extract the most value in a certain period of time in terms of monetary value. You think of it as data value sometimes. An AI first company does things like ask, well, this person we're hiring, are they really able to help us find new ways to collect data and build new predictive models? This product manager that they're hiring, do they really get that we're actually selling a prediction rather than a set of buttons? The policy discussions we're having, Are we really properly considering the implications of data protection laws? So an AI first company puts AI and data first in all of these conversations about strategy.
So just to help us visualize it a bit, how do you describe AI? Because many people kind of think of it as this giant brain in the cloud. How would you describe it? Is that an accurate metaphor or visualization of it?
I don't think of it that way. I think it's actually important to focus on the word artificial, and that is just to realize, look, it's very different to our own form of intelligence. And in a not good way, which is it can't process things in parallel like we can. We can process sound and vision and all of these things all at once and very quickly make decisions about what action to take. AIs are not very good at that yet, but they're very good at discrete things like making the same decision over and over again very reliably with a predictable output, or making very rational decisions or whatnot. So I think it's important to just remember it's different to our own form of intelligence. And that's why it's important to develop, because if it was the same, why would we be bothering with all of this?
Yep. So I'm going to jump then to a different question than what I was going to ask next, which is if an AI is good at solving problems that it sees many instances of, does that mean that it is less able to adapt when, say, the model of their world changes versus, say, a human? Think of like a black swan event or where the underlying assumptions suddenly shift.
Yeah, it can be better or worse. So it can be worse in the way you described, in that it may have only been trained on a data set that represents what's normal or what happened in the last 5 years, not what has been imbued in us over many thousands of years of evolution. So it can be worse in that way, but it can be better in that it could react more quickly. It could make a decision more quickly than us or with more confidence than us in a given situation. Or it could be able to collect data that's out of its immediate sensory abilities. Like if we're making a decision, we can only incorporate what we can see and hear at that given moment, or whatever we can collect across our 5 senses. But AIs can perhaps go and get another data source or see something that we can't see or incorporate a lot more at once. So it's both better and worse in a general sense. In a very specific sense, that's the point for business leaders to figure out, like, can it specifically make the decision I need to make better right now?
I see that the advantages that it could have in learning more quickly and accessing greater diversity of data to reorient itself. I think what would help us kind of understand is if you walk through this flywheel concept. I'm thinking about, we got to interview the former chief strategy officer for Alibaba, and he describes how Alibaba is built around this idea of observing customer behavior, learning from that, adapting the product, and then feeding it back. Or I really love this company that went public here in the United States last year, Lemonade Insurance. And their strategy is delight customers, gather data, learn from that, and then delight customers again. So walk us through your flywheel concept.
Yeah, sure. So there are multiple flywheels within a lot of AI systems, but very broadly, the idea is that if you build something that generates a really valuable prediction, so it's able to predict what's going to sell at what time, or when you're going to run out of something, or when something's not going to be available in your supply chain and you have to sort of plan around that, or when the production line might face an error that means it's going to be shut down for a while. Anyway, I could go on. When you develop something that makes a really valuable prediction, then that can attract customers. They find it super useful and they want to get into it. They want to get it on board and integrate it into their systems. And then customers, in their use of the product, generate data. They correct it. They're like, oh, that prediction was wrong in this particular instance. And then your models can learn from that correction and then go away, retrain, and then redeploy your models across not just that customer that made the correction, but all the other customers. And so then the system gets better. And then the customers either using the system more because they see it work better, or they then are able to attract other customers by saying, well, this is working really well and getting better and better. Or you're able to, in your next pitch, show our system used to be 60% accurate, now it's 80%. So the point is, as more customers use the product, they contribute more data, which makes the predictions better, which attracts more customers, which generates more data, and so on.
Can you just walk us through, say, an incumbent company, a legacy company is looking to understand where are the opportunities, maybe where are the problems? How would you approach that? Decide of all the spaces, where do we want to take an AI first or explore taking an AI first approach?
You can think about it on the demand side, which is what do we want to know next about when people might want our products? So that's a prediction problem. Or on the supply side, what do we do over and over again that's expensive, annoying, et cetera, et cetera? And so that's on the supply side. How can we supply what we do more cheaply? So that's where you start. Do we want to improve our demand side sales better, or do we want to reduce our costs? The former is a prediction problem. The latter is an automation problem. On the former, you can just think about, well, what do we keep trying to predict and keep getting wrong? And what data sets might be informative of that prediction? And where do we find them? And what methods can we try? And why don't we just throw a bunch of stuff against the wall and see how far we get? And this is what the lean AI methodology that I outline in the book is all about. Just doing that first experiment. And then on the automation side, it's, what do we know? We just do every month and it doesn't really change and we just keep doing it over and over again. So that's on the supply side. That's one way to approach it. And then, as I said, really getting into this lean AI methodology, which is a way to ask a series of questions to zero in on what predictions you can make and would be valuable. It's to just do something with one data set, one model, on one computer to generate one report so that you can figure out where would we be if we really invested in this? Would we be at 80% accuracy or 60? All right, if we're at 60, do we need to buy more data? Do we need to try different models? Or do we just need to run it over and over again so that it improves itself and spend money on computing? It just depends on where you are.
So is there a point, if you could walk us through maybe with an illustration of where you shift from the lean approach to the high CapEx approach? Because one thing that surprised me was the level of investment that is required, which creates an interesting barrier to entry and therefore a more sustainable advantage. I talked to one CEO of this company and they've been working for 4 years to develop this AI that can look at photos and then predict whether of these 10 photos of a wedding, which ones might the person find the most beautiful. And it's taken 3 or 4 years for them to get to the point where, hey, this actually is as effective or more effective or saves us time versus having humans doing it. So what's that transition like from a lean, small experiment towards going all in to making that CapEx bet?
Sometimes there's no transition. You do something with a simple model and run it on one machine and it's good enough out of the gate for that very specific, discrete thing it's trying to do. Make a prediction about stock levels in 2 months or something like that. And there are lots of known variables around what determines whether something's in stock or not, the weather, the availability, the time of year, etc. So sometimes you don't need to go much beyond that and you just move to the next problem. Other times, you do need to go and get a huge amount of labeled data, or you do need to go and take a completely different approach to modeling. You may have used a simple statistical approach and you might have to use a deeper approach that involves a neural network with a few different layers, or you might have to use one of these like very powerful decision tree type things like a gradient boosted machine or a big random forest or something like that. And not to say that they're super complicated to do and there are lots of good tools out there. A lot of people to experiment with this even without a background in this field. But sometimes you have to do that and sometimes you just have to spin up bigger systems to run the models over and over again. It's very different. Like there is no one AI, there is no one way to do it. There is no one prediction that everyone needs and every business is different. It's just a tool, just like a calculator, a computer. Our own intelligence is a tool and we use it all the time for all different things. It's so specific, but the point is, if you don't have the words, if you don't have the methods and you don't have the frameworks and you don't have the metrics, you can't even start. And so that's why I wrote the book.
Yeah, I'm talking about those words because the core idea of this outthinkers and outthinking is that when we have a problem we can't solve is because we lack the vocabulary to solve it, and language are tools, right? And so what's some of the language or some of the words that we need to start learning?
I think firstly, it's worth knowing why we can't call these things network effects or scale effects or some of these other words that we use to describe certain types of competitive advantage. And it's not a mode. It's a data learning effect and it's a loop. So firstly, it's worth understanding the difference between traditional forms of competitive advantage that we've tried to sort of adapt and use in the context of AI first companies that just aren't right in terms of describing what's going on. And then move to the vocabulary of a data learning effect, which is the automatic compounding of information, and a data network effect, and really understand what is happening and be able to describe it with words we already know, but in different combinations. And I put a lot of effort into creating an extensive glossary so that one, you have that vocabulary readily accessible, but two, you don't have to go anywhere else. You don't have to go and read some other book, some programming book or some other competitive strategy book or anything like that. Because we can describe this using words we already have. We just have to make sure we're all on the same page about what those words mean. And that's why it's helpful to have lots of people in your company have the same vocabulary so you can have more productive discussions, and have this book so that you can have more productive discussions around that.
Absolutely. Which brings me to the question of what are the barriers? And so often we start off with the barriers being the things we can see, the technology, hiring the staff, building the capabilities, the knowledge. But then there's also vocabulary, culture, mindset. As you've sought to introduce this concept of an AI first organization into companies, I know this isn't your primary job, if you will, but certainly we have legacy companies that are reading your book and saying, how do I leap ahead? What do they get wrong most often when seeking to prioritize AI?
Great question. Most often they get stuck just organizing data. And look, it's important to work on organizing your data on a constant basis, because really your database, where your data is stored and how it's organized, is your representation of reality in a form that computers can use. So we have, for a very long time, in companies that use any form of technology, spent a lot of time doing that. And we continue to spend a lot of time doing that. But when companies embark on this sort of AI first journey, they spend even more time on that. And often that's something to do, but after doing an initial experiment, because it's sort of pre-optimizing a lot of the time. So that's one big thing. Another big thing is people separate the data science and machine learning team from the rest of their team. And that's a mistake often. To some degree, that's the right thing to do because they need time and space to work on these things. But in many cases, that's a mistake because, there are very valuable things they can learn from the field, about how things really work. Like, what is the cause of, a truck getting stuck on a construction site so that the concrete doesn't get poured for 3 days? Well, what is the cause of people buying more sandwiches at 2 p.m. on some days and 10 a.m. on other days? They can sit and look at the data all day long, but they could also just walk into a store and ask someone, so why do people do this? And then they can program that into the model so it can learn more quickly. So, I think another thing is just completely centralizing or decentralizing data science and machine learning talent. That can be another problem or mistake people make. And another one is pretty common, which is just trying complicated things as opposed to simple things first, rather than simple statistical models to get you closer and closer to a better, more powerful model. You don't start with the more powerful model often. You just have an ensemble of simpler models.
Yes, that sort of multiply. All right, I have tons of other questions, but I know we're reaching the top of our time with you, so I'll limit them to just a couple more questions. So let's say a strategist listens to this podcast, they buy your book, they read your book, they buy into it. You've been on a whole number of really great podcasts that go into levels of depth that unfortunately we can't go into here. So I encourage that people also dig in there. Now they go back to their companies, they're talking to their leadership team. Their leadership team hasn't read or bought into or started making that mind shift and adapting that vocabulary. Where's a place for a strategist to start in getting their organization to start embracing what might be possible by being AI first?
Look, the obvious answer is the book that I wrote, The AI First Company. And to be fair to me, there isn't really a book focused on the strategy perspective. There are a lot of programming books and there are a lot of philosophy books. Programming books about what you do right now if you can program, and philosophy books, which are about what might happen in 100 years or 50 years. But there wasn't really much in the middle, which is the pragmatic part of the spectrum. So, you can start there. But on the website, the AIFirstCompany.com, I recommend lots and lots of other books. And I don't recommend them because they're necessarily informative of strategy, but I do recommend a lot of them because they're an entree. And look, people in business come from backgrounds in history, in biology, in computing, in engineering, from lots of different perspectives, or lots of different angles, I should say. And AI is a multidisciplinary thing. So I think it's good to have some books lying around that catch the interest of the people around you, no matter what their existing discipline is. Because you can approach AI from a biology and neuroscience angle, or you can approach it from a history angle, which is the history of tool making, or an anthropology angle, tool making and human progress. You can approach it from obviously a computer science angle. You can approach it from an engineering or a mathematics angle. You can approach it lots of different ways. So if you really just want to get to how do you develop your strategy, then that's why I wrote this book. But if you want to get others around you interested, maybe try a different approach and approach it from the discipline they know well.
Well, you've given us some really tangible things to step forward with. Thank you so much for spending the time with us. People can find you by buying your book, reading your book, which I highly recommend, going to your website, accessing the other content.
Yeah, and I'm just Ash Fontana, ASHFONTANA, on Twitter and LinkedIn and everywhere else, Gmail, everywhere.
Awesome. Thank you so much for being here with us, Ash.
Thank you.
Thank you to our guests. Thank you to our producers, Karina Reyes and Zach Ness, our editor, and the rest of the team. If you like what you heard, please follow, download, and subscribe. I'm your host, Kai-Han Krippendorf. Thank you for listening. We'll catch you next week with another episode of Outthinkers.